All right, so good morning, good afternoon, or good evening. My name is Dr. Andrew Franklin, and I'm assistant professor here at Norfolk State University, presenting you with another statistics tutorial to ensure that you understand how to go about calculating a one sample t-test. Okay, so this video is going to be all about calculating a one sample t-test by hand. So before we even get started with the particular problem that we're going to work on, let me go ahead and lay out the formulas that will be needed for this particular statistic. Okay, so for this particular statistic, you have a standard error of the mean for the sample. So that's what that symbol means. So it's the standard error of the mean for sample. And it's also the estimated standard error of the mean because it's not quite the standard error of the mean for the population. We are using the sample characteristics to estimate what the parameters would actually be like. Okay, so that S with a subscript of the capital M is the standard error of the mean. This S with a superscript of 2 is the sample variance. So this is the precursor to the standard deviation formula. Okay, so it's the last statistic that you calculate before you take the square root of the variance to get your standard deviation. And this is your sample size. So lowercase n typically is indicative of the sample size. And this is your t statistic down here. So we have a t, and then we have a capitalized M, which is your sample mean. We have a mu, which is your population mean. And we have that estimated standard error of the mean, or the standard error of the mean for the sample in the denominator. Okay, so the symbol that you see up here is the same one that you see down here. Okay, so usually with the examples that you will calculate, you will have to first calculate the estimated standard error of the mean, and then calculate your t statistic. Okay. So if you look at the t statistic, it looks just like the normal deviate z in the numerator. Okay. The only difference is there's now an estimated standard error of the mean in the denominator. And the reason why that's in the denominator is because unlike the normal deviate z examples that you had, with this t statistic, you don't know the population standard deviation. So with the problems that you'll be given as it pertains to the one sample t-test, you don't know the population standard deviation, and thus you have to estimate it, and in estimating that, you subsequently have to estimate the estimated standard error of the mean, excuse me. So these are the two formulas that you're going to need just to calculate the one sample t-test. So at this point, let's go ahead and work an example. So let's say we had a sample size of n equals 8. And in our problem, we were given a population mean of 40. And we had a sample mean of 35. Okay. And in the problem, they also told us that it would be a two-tailed test. They also said that it would be alpha level 0.05. And it was also said that your degree of freedom was 7. Okay, or maybe you had to calculate a degree of freedom. So all of these things will be given to you, with the exception of the degree of freedom. That may not be given to you. That may be something that you have to calculate. And again, that degree of freedom formula is n minus 1. Okay, so just taking our sample size, subtracting 1 from it, and that's going to give us our degree of freedom. So the number of numbers that are free to vary. So in this particular sample, 7 can vary. 1 has to be a specific number in order for all of those numbers to balance around the mean. Okay, so these are really important because these are going to allow you to obtain your critical T located in the back of your book. Okay, and that critical T is going to be really important in terms of accepting or rejecting your null and research hypotheses. Okay, so you'll have to go to a T distribution in the back of your book, and once you do that, you should come out with the critical T for this particular problem of 2.365. Okay, and there's another video that goes step by step through the Appendix B in the back of your textbook, or if you just have a T distribution table in general, go step by step through that process of obtaining your critical T. But this is extremely important in terms of accepting or rejecting your hypotheses. You need this because this is the standard that you're setting out in the tail. In particular, this is the boundary marker for the tail's 5% that's lingering out there in the tails. Okay. I failed to mention up here that you also have your variance. So it should give you your variance as well, which is 32. Okay, so all of this information is going to be given to you. Okay, so you'll have the sample size, you'll have the population mean, you'll have the sample mean, and you'll also have the variance. There may be some situations in which you don't necessarily have the variance, but you have the standard deviation. And to that end, you'd have to basically backtrack, move backwards in that sample standard deviation formula. Move backwards. Yeah, that's correct. Move backwards in that standard deviation formula. So square it in order to get your variance if you indeed have the standard deviation. So n equals 8, population mean is 40, sample mean is 35, variance is 32. Okay, so we have everything that we need to work through this formula. So we have a variance in the numerator, we have a sample size in the denominator, and we got to take the square root of it all to get our estimated standard error of the mean. Okay, so let's do that down here. So for this example, we have 32 as our variance. Our sample size is 8, and there's a square root over it all. 32 divided by 8 gives us 4, right? And then the square root of 4 is 2. All right. So what did I do? I took a few things that were given to me. In this case, the variance was given to me. So all I had to do was just plug that into my standard error of the mean for the sample formula. The sample size was given to me, so all I had to do was plug that into my formula for the estimated standard error of the mean. Then I did that equation, and I got the estimated standard error of the mean for the sample. Okay. And then lastly, you'll calculate your T statistic. So we have 35 minus 40 over 2. Okay, 35 minus 40 gives you a negative 5 over 2. And then negative 5 divided by 2 will give you a negative 2.5. Okay. So this is your calculated T. This is your critical T. Once you work your calculated T, the next step in terms of accepting or rejecting your null hypothesis and your research hypothesis is to compare your calculated T with your critical T. So what you will be trying to determine is this. You'll be trying to figure out if the calculated T in absolute value format, so just taking into account the number with the situation because it's a two-tailed test, if this exceeds this 2.365, okay? And since it does, you would reject the null and accept the research hypothesis. Okay? So even though this is a negative number, the absolute value of it still exceeds that 2.365, which indeed, since it's two-tailed, it's positive and negative. So it can be positive 2.365 or it can be lower than 2.365, and that still counts as it being out in the tails and being a significant difference from the population mean. Okay. So let's recap really quick. What did we do? Well, this is the steps for calculating a one sample t-test. And these are the formulas that you'll need. The estimated standard error of the mean for the sample and the t-statistic. Okay, we went through what all these symbols mean. It's important for you to know what these symbols mean. If you don't know what they mean, it's going to be extremely difficult for you to calculate these formulas and have an understanding of them. Then we went through the problem and we listed out everything that was given to us. So n equals 8, population mean of 40, sample mean of 35, variance of 32. You must have the understanding that sometimes you'll be given the variance, other times you'll be given the standard deviation. There may be cases where you're just given raw numbers and you have to work from the bottom to the top, so to speak. So you have to go step by step to eventually calculate your variance. This time the variance was given to you. Again, sometimes standard deviation may be given to you. Sometimes raw scores may be given to you. So based on what you've learned about the standard deviation formula, use that information to go about obtaining what you need, which is the variance for this estimated standard error of the mean. Okay. We got the critical T, and we were able to do so because we had three important tenets of information. So we knew that it was a two-tailed test, we knew that it was alpha 0.05, and we knew based on our sample size that the degree of freedom is 7. From that, we were able to look at a T distribution table and find our critical T, which is the boundary marker for, in this case, 5% in the tail. Okay, so once a number exceeds this boundary marker, plus or minus for a two-tailed test, we know that we have something that's significantly out in the tails. Then from there, we just plugged in. It's like a little kid putting together a jigsaw puzzle. So we took the variance, plugged that into our estimated standard error of the mean in the numerator for this estimated standard error of the mean formula. We took n equals 8, plugged that in, and we eventually got 2. And then we did the t statistic, calculated that, we got a negative 2.5. And then finally afterwards, we compared our calculated t with our critical t to determine if we will accept or reject our different hypotheses. Based on what we had, we elected to reject the null because negative 2.5 is lower than negative 2.365. So we elected to reject the null and accept the research hypothesis for that reason. Okay, so that's that. That's an example of a one sample t-test, really leaving out a lot of conceptual information. But this is the manual calculation side of it. Some things that you want to take into consideration when you're calculating this test. Okay, so I hope that this was helpful. Leave some feedback for me and take care.